Welcome back to Examplanet services. Now today we are starting the third aspect of the GRE Quantitative Reasoning section, and that aspect is geometry. Now in our last classes we already went through arithmetic, which is the first aspect, and went through all the topics under that. We've also discussed the second aspect, which is algebra, and we discussed all the topics under that as well. Now today we are starting the third one, which is geometry, and today we are looking at lines and angles. Under geometry we have these topics to cover. We have lines, angles, and polygons. We have triangles. We have quadrilaterals. We have circles, and also three-dimensional figures, which are also called solid shapes. Okay, so today we'll be starting with the first one, which is lines, angles, and then polygons. All right, so if you're ready, let's dive in. Now under lines, angles, and polygons, we'll be looking at lines, angles, and also polygons, just as we have in the topic. Okay, so now lines. First thing we have here is what we call line segment. And what is a line segment? This is simply a section of a line. So in GRE, the quantitative reasoning aspects, we usually come across this phrase line segment. So a line segment is simply talking about a line, but a line is said to be something that has no end, an unending thing. So we don't just call it a line in GRE, so they call it line segment. So it's just a section of a line. Okay, so the figure above is called a line segment PQ. All right, so they don't just say line PQ, they usually say line segment PQ. So just get used to that. It's still same as saying line PQ. Okay, now we have parallel lines. Now these are two or more lines that can never meet. I'm very sure you are used to that kind of definition. Of course, two or more lines that when you extend them, they can never meet, no matter how long you extend them. So they are called parallel lines. Now, not all lines that look parallel are actually parallel in GRE. They can always draw two or more lines looking very parallel, but that does not mean the lines are parallel. So there are things you should look for in order to be sure that the lines are parallel before you can treat them as parallel lines. Okay, now first is they can express it in a statement like this. For instance, according to these two, you see line M is parallel to line N. So if they write it in words like this, then you can say the lines are parallel, and you can treat them as parallel lines. That's one way to know if the lines are parallel. Number two, another way to know if the lines are parallel is if they use this symbol parallel lines. M is parallel to N. Okay, so that means the lines are parallel once you see this symbol. So usually they will name the lines definitely, and they can put the symbol there. So that means the lines are parallel. Okay, now another way you can know if two or more lines are parallel, if they don't put it in words and they are not using this symbol, is if those lines make the same measure of angle with another line. Okay, if they make the same angle with another line, then they are parallel lines. That is, what I'm trying to say is this. So let me say I have this line, okay, and I have another line like this, and then these two lines, maybe there's another line joining them this way, and I can see here maybe 30 degrees, and also see here 30 degrees. So since these two lines, M and N, make the same angle with this line K, for example, then M is parallel to N. Okay, so once they make the same angle with another line, they are parallel lines. So I could have something like this, maybe this, I have this, and I have this, and I can see 90, 90, maybe A, B, C, D, E. So since line AE and BD make the same angle with this AC, then AE is parallel to BD. So that's another way to know if two or more lines are parallel. Okay, so with those 3 ways, we can know and be sure that our lines are parallel. So if you don't see any of those 3 points, then it's not likely the lines are parallel. It is not likely the lines are parallel. So they may be looking so parallel. That doesn't mean they're parallel. Always look for confirmation. Always look for an information to be sure the lines are parallel. All right. Now, next one is perpendicular lines. Now, these are 2 lines with angle 90 degrees between them. So 2 lines with angle 90 degrees between them, they are called perpendicular lines. Don't forget that this is an angle 90 degrees. Every other angle is shown with a curve. Only 90 is shown with something like this. Okay, so this line M and N are perpendicular because they have angle 90 degrees between them. So to also be sure that your lines are perpendicular, always don't just look at the way they look for an information. And 3 ways as well to know if they are perpendicular. Number 1, they can write in words like this: line M is perpendicular to line N. That's one way to know the lines are perpendicular. Number 2 is if they use the symbol of perpendicular lines. As you can see here, this symbol of perpendicular lines. So this means line M is perpendicular to line N. And another way, the 3rd one, is if you see angle 90 between those 2 lines, then they are perpendicular. They are perpendicular. So you look for any of these 3 points to be sure the lines are perpendicular. If you don't see any of them, then you have to be very careful. They may not be perpendicular. They may not be perpendicular. All right. So that's what I mean by perpendicular lines. Now let's talk about angles. Now, an angle is formed when 2 or more lines meet at a point. Once a line meets another line, an angle will be formed between them. And the point at which they meet is called the vertex. So for example, this is a line, and this is another line here, and then this is the angle between them. This is the angle. Now they meet at this point, so these 2 point lines meet here. So the point at which they meet is called the vertex of the angle. So we call it vertex. All right. So this is the vertex of the angle, and this is the angle. Now, angles are classified according to their degree measures. So we have different kind of names of angles that you can, I believe you can remember them now. First, you have what we call acute angles, and any angle that is less than 90 degrees is called an acute angle. All right. And we have a right angle, which is 90 degrees. So in here, right angle, it means 90 degrees. 90 degrees. So a right angle is equal to 90 degrees. We have an obtuse angle, which is an angle that is greater than 90 degrees but less than 180. Okay, greater than 90 but less than 180, like maybe 91, maybe 100 degrees, maybe 125 degrees, maybe 179 degrees. Any angle that's greater than 90 but less than 180 is called an obtuse angle. Then we have angle on a straight line. Angle on a straight line. That is an angle that measures 180 degrees. It measures 180 degrees. So an angle on a straight line is equal to 180 degrees. Okay. Now we have what we call a reflex angle. A reflex angle is an angle that is greater than 180 but less than 360 degrees. Greater than 180 but less than 360 degrees. So they are called reflex angles. They are called reflex angles. So when you see angles like 181, angle 200 degree, angle 310 degree, angle 345 degree, these are called reflex angles. They are greater than 180 but less than 360 degrees. Now we have angles at a point. And angles at a point measure 360 degrees. They are angles that can form a closed circle. All right, a closed circle. The total is 360 degrees. Okay, so out of these angles, majorly it is not about the names. It's for you to be able to recognize them majorly. All right, be able to recognize them, and that is what helps to be able to see or to know the values of the angle. So when you see angle on a straight line, or you see angle at a point and all that. Okay, so for example, when you have something like this, I can have this angle, this angle, this angle. So maybe A, B, and C. So these 3 angles together, as you can see, they make a straight line. A straight line. So it means my angle A plus B plus C was 180 degrees. 180 degrees. Okay. It can be anyhow. I can have something like this. So this angle and this angle, maybe X and Y. So together, as you can see, they make a straight line. So that means x plus y must be 180 degrees. All right, so those are what we mean by angles on a straight line. They can be more than 3, they can be 5, they can be 2, they can be 1. It can be only one angle, they can be 7. As long as they can together make a straight line, then the sum must be 180. And also, angles at the points, something like this, this. Can have W, X, Y, and Z. So when these angles, we join them, they can form a closed circle. A closed circle. So that means W plus X plus Y plus Z, they are equal to 360 degrees, the sum. That's what we call angles at a point. As long as they can all make a closed circle. You can have something like this, and maybe like this. Okay, so this angle. So maybe A, B, C, D, E, F, G, H, I. So together they can form a closed circle. So it means my A plus B plus C plus D plus E plus F plus G plus H plus I. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 angles. Total must be 360 degrees. Of course, because they can form a closed circle. That's what we call angles at a point. So those are some key angles that you have to be able to recognize when you see them. All right, now we have what we call angles between lines. Okay, angles between lines. Number one is what we call alternate angles and corresponding angles. Now, these two angles, they are formed when you have parallel lines. So if a pair of parallel lines is cut by a transversal, alternate angles and corresponding angles are formed. Okay, when a pair of parallel lines is cut by a transversal. So these are parallel lines. For example, we are using arrows here, though in GRE we don't usually use arrows to indicate parallel lines, but we are using arrows here for instance, and there is a line crossing them. So this line crossing them is what we call a transversal. Now, when we have something like this, once you have a transversal crossing parallel lines, then these two angles are formed: alternate angles and corresponding angles. Okay, now from this diagram, where are the alternate angles? The alternate angles are C and E, and alternate angles are always equal. They are always equal. So angle C and angle E, they are alternate. So they usually form a kind of something like a Z. That's one thing you have to understand here. All right. So for example, check this. Can you see something like this? Something like this. So like a Z. So this angle and this angle, they are alternate and they will be equal. Right. So they form something like a Z like that. Okay. So these are alternate angles. This angle and this angle, they are alternate angles and they will definitely be equal because these two lines are parallel lines and there is a transversal crossing them. Okay, so that's what we call alternate angles. So C and E are alternate. C and E are alternate. Another one is D and F. D and F, they are also alternate angles. D and F are also alternate angles. So for example, look at the shape, more like a Z as well. They may not be a perfect Z, but something like that. Okay, so they are alternate angles. So angle D and angle F, they are alternate angles. So when you see all these kind of shapes, then you have alternate angles. So you could use like something like N, something like this. So as long as this is parallel to this, so this angle and this angle, they will be alternate and they will be equal. Okay, so you can have it anyhow, forming like a Z. So this line parallel to this line, this angle, alternate and equal. Okay, so those are what we call alternate angles. Alternate angles, you can have them anyhow. Could be something like this. Okay, as long as this is parallel to this. All right, so this angle here and this angle here, they are alternate and equal. So that's one by alternate angles. Okay, so another one is corresponding angles, and like I said, they also form when you have parallel lines and a transversal crossing them. And you can see here we've picked some of them. For example, angle D and angle H. D and H, they are corresponding angles because we have parallel lines and we have a transversal. So D and H. So corresponding angles, they just take this kind of similar shape in forming, and that's what you can use to know which of the two are corresponding and equal. So like I said, D and H, let me show you here. So we have my D, something like this, as you can see, and then my H, something like this. So you can see that just taking that kind of shape. So more like you're just having this. So as long as these two lines are parallel, and probably this is just a straight line, then this angle is corresponding to this angle, so they'll be equal. So that's why you're having a D and H. They are corresponding angles. Other ones are angle B and angle F. As you can see, B and F, they are corresponding angles. So you have this kind of shape from them. You can see here and here. Okay, so you just have that kind of shape like that. This. So as long as these two lines are parallel lines, so this angle and this angle, so this could be straight line, majorly straight line. So these two angles are corresponding angles, and they will be equal, corresponding and equal. So that's one by corresponding angles. So you should be able to recognize them when you see them: alternate angles, corresponding angles, and all that. Okay, so you can have different shapes for the corresponding angles. So you can have something like this, and then maybe another one like this. So as long as these two lines are parallel, this is parallel to this, so this angle and this angle, so this could be a straight line. All right, so they are corresponding angles. So now, from our parallel lines and the transversal, as you can see, we can pick our corresponding angles and alternate angles. Like I said, they must always be equal. So alternate angles are equal and corresponding angles are also equal. Okay, now 4 of the angles are acute and 4 are obtuse. That is, we're talking about this shape here. As you can see here, we have acute angles and we have obtuse angles. Remember, acute angles are angles that are less than 90. And if you check, can you tell me what you are seeing here? What are the acute angles? A and C, and also E and G. Those are acute angles. They are less than 90 degrees. A, C, E, G. Okay, so they are 4 and they are less than 90, and they are acute angles. And also B, D, F, H, they are obtuse angles because they are greater than 90 but less than 180. Okay, so when we have this kind of shape, of course, we'll have 4 acute angles, 4 obtuse angles. So now the bottom is the 4 acute angles are always equal. So A is equal to C, equals to E, and also equal to G. So our angle A must be the same as our angle C, and C must be equal to E, as you know they are alternate, and E must be equal to G because G is also corresponding to C, and E is corresponding to A. So if A is corresponding to E, that means they are the same, and if C is corresponding to G, that means they are the same, and A must be the same as C as well. Okay, so all the 4 acute angles are equal, and also all the 4 obtuse angles are also equal. That is, B is equal to D, is equal to F, and is equal to H. Okay, as you can see here, B corresponding to H, they must be the same. D corresponding to F, they must be equal. So the 4 obtuse angles are also equal. So now the sum of any acute angle and any obtuse angle is 180 degrees. Okay, sum of one acute and one obtuse is always 180 degrees. Like for example, A plus B is 180. As you can see, they make angle on a straight line. A plus B is 180, they make a straight line. Okay, and also F plus G is 180 because they also make a straight line. F plus G, 180 degrees, they make a straight line, the two of them. F plus G, 180. So if you had one acute and one obtuse, you will get 180 degrees as long as you have two parallel lines and a transversal crossing there. Okay, so that's what you need to understand here. Now we have another one which is called the opposite angles. The opposite angles. Now the opposite angles are formed by two intersecting lines. When one line crosses the other, then you have opposite angles formed. And opposite angles are also equal. Okay, so angle A is opposite to B, and they are equal. As you can see, angle C is opposite to D, and they are equal. So opposite angles are always equal. So when you have two lines crossing each other like this, you have opposite angles. So these opposite angles have nothing to do with parallel lines. We don't need parallel lines for opposite angles can be formed. Once you have two lines crossing each other, then opposite angles are formed. So A is equal to B and C is equal to D. So they are called opposite angles. Now A and C together they form a straight angle on a straight line. So the sum is 180. B and D also they form angle on a straight line. So the sum is 180 degrees. Now if you add A plus B plus C plus D together, they can form a closed circle. And that is what? Angles at a point. So the sum of the four angles will be equal to 360 degrees. Be equal to 360 degrees. Okay, so these are the angles you should be familiar with. Opposite angles, alternate angles, corresponding angles, angles at a point, angles on a straight line, and so on. Okay, so those are the key things you need to note about angles. When you have angles on a line, angles between lines, how we calculate them, and the relationship between the angles. All right, now let's look at an example here. Okay, so this example says line K is parallel to line M on this diagram. Now quantity A, X plus Y, quantity B, W plus Z. K is parallel to M, A, X plus Y, B, W plus Z. So from what we've discussed so far, you can also pause the video, try to look at the diagram very well, and pick your answer, and then check to see if you are correct. All right, now let's see the solution to this question. Now, so from the diagram, as you can see, we're told already that M is parallel to K. So if M is parallel to K, so now it means, for instance, angle X is alternate to Z. All right, which means X is equal to Z. As you can see, since these lines are parallel, so this angle is equal to this angle. All right, now also it means angle Y is alternate to W. As you can see, this angle and this angle. So Y is equal to W. They are alternate angles. Therefore, so if X is equal to Z and Y is equal to W, then what does that mean? It means X plus Y, that's this, must be equal to Z plus W, this. So which means the two quantities are equal. So answer will be C. So that is the solution to the question. The two quantities are equal. So our answer will be C. Quantity A is equal to quantity B. Okay, example 2. It says in the figure above, if R over R plus S is equal to 5 over 8, what is the value of R? Can you see this diagram? What can you say about R and S? What is the relationship between them? Okay, you can pause the video, try to solve the question from what we've discussed, and then continue the video to see the solution. All right, so let's check the solution to this question. Now, from what we can see here, angle R and angle S, what can you see? Together they make angle on a straight line. So that means our R plus S is equal to 180 degrees, angle on a straight line. So therefore, according to this statement, that means r over r plus s, which is 180 degrees, is equal to 5 over 8. So what do we do here? We cross multiply, and that means r times 8 will give us 8r, which is equal to 5 times 180, which will be 900. Okay, so that means our r will be 900 divided by 8. And when we divide 900 by 8, what do we get? R is 112.5 degrees. That is our angle R. That's our angle R. Okay, so that is the solution to example 2. I hope you got the same answer. Alright, so we type our answer here, 112.5 as the value of R. Okay, now quickly to the last part of the lesson, which is polygons. Now polygons are closed plane figures with straight sides. So when I talk about polygons, I'm talking about figures that are closed and they have straight sides. Okay, so your polygon must be closed. If it's not closed, then it's not a polygon. It must be closed and the sides must all be straight. So it can be anyhow. They may be equal, the sides may be equal in length, they may not be equal in length, but as long as they are closed and they are straight, you have a polygon. Now what we call regular polygon. Now these are polygons with equal side length and equal angle size. So in a regular polygon, all the sides are equal in length and all the angles are equal in size. Okay, so as you can see here, we have these angles all equal, x, 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 x. So if all the angles are equal, then definitely all the sides must be equal in length. Or if all the sides are equal in length, then all the angles must be equal in size. So meaning we have what we call a regular polygon. So the x is called interior angle, while the y is the exterior angle. As you can see, this is interior, this is exterior. Okay, so that is what we mean by regular polygon. So if all the interior angles are equal, then all the exterior angles must also be equal. So that is a regular polygon. Now note this, the sum of the interior angles of any polygon is given as n minus 2 times 180. N minus 2 bracket close times 180. That's calculate the sum of the interior angles of any polygon. So where n is the number of sides of the polygon. Okay, n is the number of sides of the polygon. So which means if we need to find the sum of the interior angles of a pentagon, for example, of a pentagon, all right, sum of the interior angles of a pentagon, we got what? So now remember that pentagon has how many sides? Pentagon has 5 sides. Pentagon has 5 sides. Okay, so now the formula is n minus 2 or bracket 180, and forget n is the number of sides of the polygon. So if I find the sum of the interior angles of a pentagon, that means our n will be 5. So we are going to have 5 minus 2 bracket 180, and that will be 3 times 180, and that will give us 540 degrees. That's some of the interior angles of a pentagon. They may be equal and they may not be equal, because if you have 5 sides, you must have 5 angles. If you have 6 sides, you must have 6 angles. Okay, hence the size of each interior angle of a regular polygon is given as n minus 2 bracket 180 divided by n. That is, now if the polygon is regular, and want to get the size of each interior angle, that means all we need to do is to divide the sum by the number of sides, since they are equal angles. So for example, we just calculated that of pentagon, which we got 540. So that means to get the size of each interior angle, if the pentagon is regular, then we divide 540 divided by n. We divide 540 by n, which is 5, and that will give us the size of each interior angle. Now the sum of the exterior angles of any polygon is equal to 360 degrees. Okay, any polygon at all the sum of the exterior angles is 360 degrees. Even if the polygon has 1 million sides, if you add all the exterior angles together, you will get 360 degrees. Hence, it means if the polygon is regular, then the size of each exterior angle will be 360 degrees divided by the number of sides, n. So any polygon at all, if you want to know the size of each exterior angle, as long as the polygon is regular, just divide 360 by the number of sides of that polygon, and that gives you the size of each exterior angle. Okay, now the number of triangles in a polygon with n sides is given as n minus 2. Alright, so the number of triangles you can form in a polygon with n sides will be n minus 2. So for example, in a pentagon, the number of triangles you can get in a pentagon is 5 minus 2, because the number of sides is 5. So 5 minus 2. Alright, let me show you that. Now we have a pentagon. Let me just draw a pentagon here. Anyhow, has 5 sides. So if I want to form triangles, I would join a vertex to any vertex that is not next to it. So this is how we call vertex. Okay, it's a vertex, this is a vertex, this is a vertex. So I will join this with this, I can join this with this, and I can also join, as you can see now. So I have this, I have 1, 2, 3 triangles formed. Alright, 3 triangles formed. So because I have 1, 2, 3, 4, 5 sides, so no triangle will be 5 minus 2. So 3 triangles, 1, 2, 3. Those are 3 triangles I have in the pentagon. Alright, so that's what I'm trying to say there. Alright, so now another point to note is that the number of diagonals from one vertex of an n-sided polygon is given as n minus 3. Okay, the number of diagonals from one vertex of an n-sided polygon is given as n minus 3. That is, if you pick a vertex in your polygon, the number of diagonals you can draw there is the number of sides of the polygon minus 3. Minus 3. So, for example, let's say we have a quadrilateral which has 4 sides. Anyhow, can be anyhow. It's a quadrilateral, 4 sides. Okay, so now if I want to draw a diagonal from any of the vertex, let me say this vertex now, this vertex here, the diagonal is this. So I can only draw one diagonal. I cannot draw diagonal this way. I can't come like this. I can't come like this. No, it can only be this way. Okay, so that's because I have 1, 2, 3, 4. 4 sides minus 3. So I can only draw one diagonal from each vertex. If I want to draw from here to, it comes like this. If I want to draw from here, I can only draw one, which will go like this. Same way. So if I have a pentagon, okay, how many diagonals can I draw from each vertex? Number of sides minus 3. So I can only draw 2 diagonals. If I pick this vertex, that means this one and this one. Yeah, if I pick this vertex, I can only draw this and this. Okay, so that is what we mean by that. So only if you pick a vertex, the number of diagonals you can draw will be the number of sides of the polygon minus 3. Okay. Now we have these facts about polygons that we can note. Number 1, the sum of an interior angle and an exterior angle of any polygon is equal to 180 degrees. Alright, so that is when you add one interior and one exterior angle of a polygon, you always get 180 degrees. For instance, if you check this polygon here, you will see one exterior plus one interior. Together they make a straight line. So the sum must be 180 degrees. Alright, another one exterior, interior, together they make a straight line. So that will be 180 degrees. So the sum of one exterior and one interior angle will give you 180 degrees. Number 2, if the number of sides of a polygon increases by 1, the total interior angle will increase by 180 degrees. Okay, do you get that? If the number of sides of a polygon increases by 1, then the total interior angle will increase by 180 degrees. So that is, for instance, let's check what we are talking about here. Let's find sum of the interior angles of a quadrilateral. So remember, quadrilateral has 4 sides. So this will be equal to 4 minus 2 times 180. And that will be 2 times 180, which is equal to 360 degrees. Now let's increase the size by 1. That means you're not going to have pentagon. Alright. So sum of the interior angles of a pentagon will now be what? 5 minus 2 bracket 180, and that gives us 3 times 180, which is 540. So if you find the difference between 540 and 360, what do we get? 540 minus 360 gives us 0, and you have 8, and you have 1. So the difference is 180 degrees. So that means increasing the sides by 1 means the total interior angle will increase by 180 degrees. Okay, so just a point we can use in some questions to make our work faster. Alright. Okay, so now we have names of polygons. As you can see, the names and the number of sides they have. So the first is triangle, which has 3 sides, as you know. Triangle, 3 sides are called triangles. Now 4 sides, we have quadrilaterals, like your rectangle, like your square, and so on. 5 sides, we have pentagon. 6 sides, we have hexagon. 7 sides, we have heptagon. 8 sides, we have octagon. 9 sides, you have nonagon, and 10 sides, you have decagon. So you must know the names, because in most times when they give you questions on polygons in GRE, they only mention the names. So you have to know the number of sides that polygon has. And if they're going to give you anything outside these ones, they will tell you the number of sides, definitely. But once they give you any of this, they will only mention the name. They will not tell you the number of sides. So when they mention the name, you should know the number of sides, because you know that anything was calculated about polygons, you really need to know about the number of sides of the polygon. Alright, so now let's get these few questions to wrap up the class. Okay, now this question 1, it says you have a figure here. As you can see, in the figure shown, lines K and M are parallel to each other, and Y is equal to 180 minus W. Quantity A, X, quantity B, Z. Okay, can try to look at everything we've talked about under these lines, angles, and polygons. Remember the alternate, the corresponding, and all that, and look at this question. You can pause the video, try to solve it by yourself, and then continue the video to see the solution. Okay, so let's check the solution to this question here. Now let's check the solution to the question. So here, as you can see, K is parallel to M according to the question. So that means we can now see this as a transversal. We can see this as a transversal. So we can expect to see alternate angles and corresponding angles or whatever here. Okay, now we have been given an information that Y is equal to 180 minus W. So X and then Z. X and Z. Which one is greater, or are they equal? Okay, so what can we do here? Now, since we are given an information about Y and W, Y is equal to 180 minus W, I will look at my diagram and see if there is any way I can connect Y and W. And as you can see here, it is difficult to really see how you can connect them together from this diagram, because they have been combined with these parallel lines using different transversals. So it will be difficult. Now, what can we do? Let's take Y with X and see what we can produce. And if you look at Y and X together, they make angle on a straight line. So it means X plus Y must be equal to 180. Okay, X plus Y must be equal to what? 180. Therefore, I have two equations here. This one, this one. So what we need to do is to see how we can connect these two equations together. Okay, and what does that mean? In place of 180 here, I will put X plus Y there, since X plus Y is 180. So therefore that means I can say my Y will be X plus Y minus W. Now in that case, what can we say here? I can say that Y minus Y, that is bringing this Y to the other side here, will now be equal to X minus W. Yeah, so then what can I say? I can say Y minus Y will be 0 is equal to X minus W. And what does this mean? It means my x is equal to w. Oh, alright. So x is w. If x is equal to w, that means I can write this to be equal to w. Now, from this, what can you see? We can see alternate angles. Alternate angles. Alright? That's W and Z, because these lines are parallel. W and Z. So they are alternate angles. Hence, it means that my W is equal to Z, because they are alternate. My W is equal to Z, and W is equal to X. So what does that mean? It means my X is equal to Z. So the two quantities are equal. Okay, so that is how we can simply solve this question, putting our reasoning into play there. Okay, so our answer will be C. Alright, the two quantities are equal. Now the next question, it says if the total interior angle of polygon A is 360 degrees more than the total interior angle of polygon B, then polygon A is how many more sides than polygon B? Okay, let's read it again. The total interior angle of polygon A is 360 degrees more than the total interior angle of polygon B. Then polygon A is how many more sides than polygon B? As you can see, do you think we need anything to calculate here? Not really. Remember this point? If the number of sides of a polygon increases by 1, the total interior angle will increase by 180 degrees. 180 degrees. So that means, since the question is saying that polygon A, the interior angle of the polygon A is 360 degrees more. 360 degrees more. That means twice this one. Twice 180. Alright? So it's 360 degrees more than the total interior angle of polygon B. So 360 degrees is twice 180. And what does that simply tell us? It simply means polygon A is 2 sides more than polygon B. Yeah. I can tell you this is one of the hard questions you can see in GRE, but I can see if you remember that point, you say to it in 5 seconds. You don't need to calculate anything. So since A is the interior angle, total interior angle of A is more than the total interior angle of B by 360 degrees, that's twice of 180, then polygon A must have 2 more sides than polygon B. Hence, our answer here will be 2. Our answer here will be 2. Okay, so that's about lines, angles, and polygons. Alright, so that's just like an introductory aspect of geometry. So from the next class, we'll go in full details to our polygons. That's starting with triangles, then to collaterals, and so on, like that. So try to go through the videos again, try to practice the questions there, search for more, remember all those points, and then you'll be good to go. So, and you need to try and make sure that you studied all this very well, so that we can move on smoothly in the next class, which is going to be on triangles. So see you then.